students. In this session, we will be mainly discussing the topic earthquake, definition of earthquake, three waves which are generated by earthquake and their importance. They are primary waves, secondary waves and long waves. Then causes of earthquake like volcanicity, folding and faulting, etc. Then we discuss the distribution of earthquake like the circum-Pacific belt, mid-mountain belt and mid-Atlantic belt. All these three important areas are there when we discuss about distribution of world earthquake. Then we discuss the important areas of earthquake in India. That means we discuss the important zones of earthquake in India, mainly Indo-Gangetic Plain and Deccan region, etc. Children, before starting the topic earthquake, we should know some important and interesting facts. Which are those facts? You know that the earth crust is divided into several tectonic plates. You can see that plates here. Okay, these are divided into several tectonic plates, and the scientist says that these tectonic plates are moving. How are these tectonic plates are moving? Let's see. Children, millions of years ago, you know that there was only one single continent. The scientist says that instead of 7 continents, there existed only one single continent named Pangaea. Later on, this Pangaea divided into 2 continents. They are Laurasia and Gondwanaland. Okay, so how did it happen? Why? Because the scientist says that some kind of movements are taking place under the earth. So we learned that how it happens. You see that we learned that the earth crust is divided into 3 important layers, which are the crust, mantle and core. Now you see mantle here. You can see mantle here, and mantle can be divided into upper mantle. This can be divided into upper mantle and lower mantle. Upper mantle and okay, then this below that lower mantle. Okay, now scientist says that this upper mantle you see fully molten form. Okay, upper mantle the rocks are in the molten form due to high temperature. Again, lower mantle is little harder than this upper mantle, so that upper mantle can be called as asthenosphere. It can be called as asthenosphere, and lower mantle can be called as mesosphere. Okay, now you see the scientist says that this asthenosphere, that means upper mantle, is floating above the mesosphere. Now what else is floating? Here the crust consists of both oceans and continents. Okay, both oceans, continents and the upper mantle is floating above the lower mantle, that means mesosphere. So what is asthenosphere? The part of crust and the upper mantle is considered as asthenosphere. So asthenosphere consists of both oceans and continents. So that means all the tectonic plates, we learned that the earth crust is divided into several tectonic plates. So all these tectonic plates are floating above the mesosphere. Okay, so it is mainly due to this fact we can say that some kind of movements are always taking place. What kind of movements are taking place? You see under the earth, you see as you go, you understand that mantle, upper mantle, you see it is in the molten form magma. So high temperature is generated. Moreover that due to the presence of radioactive elements, you see there forms conventional currents. So what is responsible for the movements of these tectonic plates is mainly the conventional currents which are generated under the earth. Okay, which are generated below the upper mantle. Okay, what is that? Conventional current which are generated in the upper mantle. You see this, children. For an example, we can say that coffee or tea, the cup when we keep the milk coffee or milk tea, what happens after sometimes when you can say a kind of what is that, on the top the layer is formed, isn't it? Similar way you can compare this with that, like continents, isn't it? The crust This is upper mantle. So it's like you can say the layer which is formed on the top of a liquid like tea or coffee, like, isn't it? This is what. So these but the crust, it is divided into several tectonic plates. So due to the conventional current, these plates are keep moving. Understood? So that is the reason why in the beginning there was only one single continent. Later on it was divided into two continents. Okay, why? Due to the conventional current they started moving. Okay, then again these are divided into what is that? North America, Europe, Asia, and what is the Antarctica, Australia, India, South America. Okay, now you can see India. It's a wonderful factor. That means you see where you can see India here. It is with Antarctica and Australia. Do you think now India is here? No, India is with now Asian continent. How did it happen? The scientist says that this India started moving towards the north. Indian continents started moving towards the north. Isn't it so? It started moving towards the north. North, which continent is there? There, Asia is there. Okay. So it started moving towards the north, and later on it came and collided with Asian continent. You can see now how did it came and collided with Asian continent. That means here it is this is Indian plate we can say, and it came and collided with Asian plate. Okay, Asian plate. Otherwise we can also say that this part as the Tibetan plate. Okay, Tibetan plate is a part of major Asian plate. So it came and collided. So due to their collision, you see in the northern part of India there formed a mountain, a huge mountain. Which mountain is the range is that? Himalayan mountains. The great Himalayas are formed. Then how did this Himalayas are formed? Scientist says that you see, we learned that you see the plates are moving. Suppose these are the two tectonic plates. This is an example. Okay, these are the two tectonic plates for example. Okay, so how did it happen? They move towards the same direction. Here you see this has happened. So Indian plates moved towards the north and came and collided. Once they moved towards the same direction, what happened? When this kind of movement take place, means there take place a collision, isn't it? They collide. So due to the collision, there formed a folding. You see this kind of folding. This is how. So when this kind of folding on the earth crust, there forms mountains. What kind of mountain? Fold mountains are formed. So Himalaya is a fold mountain. Understood how did this fold mountain is formed? Clear? There are mainly three types of tectonic plates are there. You see divergent tectonic plates, otherwise divergent movement. Okay, you see that here this movement of the plates are like this. From a main point, from a particular point here, it moves towards the different direction. This is divergent plate boundary we can say. Scientists say that block mountains are mainly formed due to this kind of divergent boundary. And next is that you see convergent boundary. Convergent we discussed already about Himalaya. Okay, they move towards the same direction and they collide each other. So there forms a faulting, and that what happens, this there forms faulting. You see this kind of faulting. Okay, so that there forms fold mountains. Okay, now you see this is called block mountain, divergent boundary. This kind of movements of the tectonic plates take place. This is called mainly faulting. This process is called faulting. What is faulting? And in the what is that? When the tectonic plates move into different direction, what happens? There causes faulting of the earth crust. So this causes the formation of what is that? Block mountains, and in this case it is a convergent movement. Then what happens? Convergent movement, then see they move towards the same direction, will cause the formation of fold mountains. Example is Himalaya. We have seen that. Okay, next is transform boundary. You see, sometimes the movement of the plates take place like this, parallel to the opposite direction. Okay, this is called transform boundary. How does? So let's see some feature like this, how it is formed. You see, transform boundary is shown here. You see what kind of feature is formed here on the earth due to the transform boundary. Is it clear? Now convergent. So you see, yes, let's see. You see, convergent boundary. Convergent boundary means, you see, when they move towards the same direction, when the force is applied towards the same direction. Otherwise, we can say when the two tectonic plates moves, what you can see fold mountain. Okay, you can see all these are the fold mountains. Even faulting is also there. You can see means when move towards a different direction, faulting also appears like fold mountains. Sorry, faulting causes the formation of block mountains. Clear. So again we can classify the plate boundary as oceanic plate and continental plate. How is it? You see, children, in this figure you can see this is oceanic plate. Okay, this part is oceanic plate. You can see here oceanic plate, and this is continental plate. Most of the time you can see continental plates are thicker, but still they are lighter than oceanic plate. Okay, they are lighter than the oceanic plate. Okay, these are the, so you see Pacific Ocean, we learned about ring of fire and all. You can see this ring of fire is, in the last class we learned about, when we discussed about volcano, we learned that ring of fire, these are, even the earthquake, these all take place mainly at the boundary of oceanic plates and continental plates. You can see here, you see here, this is a boundary, you can see here form, isn't it? This is a continental plate and this one is the oceanic plate here also. So this is a ring of fire, we learned that Pacific Ocean, and this is mid-Atlantic ridge, earthquake prone area, the distribution of earthquake we are discussing. So the Pacific belt you see here also, Pacific belt, both the side Pacific belt. Okay, this both the side, these are also known as ring of fire. When we discuss about volcano, these region are also, you find maximum number of volcanoes in this ring of fire, both the side of Pacific region, and these regions are also you can find these are also the earthquake. That means wherever the volcanoes are there, those regions are also prone to earthquake. Why? Because volcano means weak earth crust. When the volcanic emission take place, that means the crust is, balance is lost, and so that will cause vibration there, earthquake. So volcanic regions are also prone to earthquake. So ring of fire, that means Pacific belt, and this is also Pacific belt. And then other than that, what is that, mid-Atlantic ridge, we are discussing about distribution of earthquake here. Okay, this is a mid-Atlantic ridge. Then mid-mountain belt, which is mountain belt here. Yes, it starts from here, it ends up to Himalayas. Like these are the mid-mountain belt. So when we discuss about distribution of earthquake, we discuss about which one? Pacific belt. First one is Pacific belt. We found about Pacific belt, where it comes. Then mid-Atlantic ridge. This is the mid-Atlantic ridge. Pacific belt, you can see here, both the side Pacific belt, and this is mid-Atlantic ridge. Then so this is also Pacific belt. Okay, and then mid-mountain belt. Is that clear for you all? Yes, distribution of volcanoes. Children, let us now define the term earthquake. It will be very easy for you to understand. What is earthquake? Earthquake is a sudden trembling or series of vibration or shock waves in earth crust which occur due to the sudden disturbance produced by internal or tectonic plates. So you understood, earthquake means what? It is a sudden trembling or vibration, or it can be a sudden shock. Why? How does it happen? Due to the disturbance which happened in the tectonic plates. How did it have the disturbance took place? Because of the conventional current which work under the earth. So due to that, their movements, and also because of the convergent and divergent boundary. And what is the convergent, divergent and transform boundary? You understood the different type of movements of the tectonic plates. So due to all these things, what happens? Sometimes there can go. So due to the movements of the tectonic plates and the conventional currents which work under the earth, and sometimes there occur trembling or what is that, vibration or shock waves in the earth crust, is which causes the disturbance produced by the internal or tectonic forces are called what? Earthquake. So you need to underline this definition and study. Clear? So next we discuss about three type of waves. When we discuss about three type of waves, let's see, there are mainly three type of waves in the lesson. It is given: primary waves, secondary waves and long waves. Okay, what are these primary? These waves are mainly produced at the time of earthquake. Okay, so what is special? So what is the importance of these waves? You know, these waves are mainly helping us to know about the interior structure of the earth, because we cannot directly go and study about the inner earth. Okay, so that at the time of earthquake, so scientists, they study the nature of these waves, and then they understand the what is that, internal structure of the earth. So what is it? P waves. P waves are the fastest moving waves, earthquake waves. They can pass through gases, liquid and solid. Okay, they can pass us through, remember here, they can pass us through all the three objects like gases, liquid and solid, and what their velocity increases as they passes through the mantle, but velocity drops down outer core. That means, you see, mantle, the solid, their speed increases in what is the liquid. Mantle is in almost molten form, so liquid form, the speed is, velocity increases, but in the what is that, outer core is somewhat solid it is. Why? Because of the extreme pressure of the overlying layer that remains solid. So solid, its speed decreases. So you have to only understand that what primary waves passes through gases, liquid and solid. Then secondary waves, these are the waves, they travel through solid only. They can only travel through the solid, and they cannot penetrate into the dense molten core. That means they cannot get into. Understood? So clear. So next is that long waves. These long waves are, they are the very slow waves, and they travel along the surface of the earth. So understand the difference. Primary waves, they can pass us through gases, solid and liquid. Secondary waves, they can pass us only through the solid, and long waves, they can pass us through only the surface of the earth. So according to their nature, scientists study about the interior part of the earth. So that is the important